So I have explained that this is a simplified simulation of coronavirus or COVID-19 virus. And here we have several parameters that we can tune to do this modeling. And basically in this model we have a current population of 200. Some of them are elders that are visualized with this kind of walking stick, and one individual in the population is infected. Its infected or sick people are shown in red. The distribution of population is random, and we can run a simulation to see how the virus spreads along the population. Here we see the curve of sick people up to almost 55 people got simultaneously the disease, and here we can see the evolution of sick people and healthy people, how when sick people increase, healthy people decreases, and some of the infected people get immune, so immune people, the population increases, and in fact 75% of the regular people recover, but this percentage is much smaller for elders. I also can tell that I can change the way individuals are represented, so we might have circles, or we might have people but not distinguishing elders, or we might have this personage display where we distinguish those individuals that are older than 60 years. In any case, individuals in red means they are sick, and in green means they are healthy. Let's see how it is done. All the explanation of the model appears in the information tab. So here I do reference the model I've been based this other coronavirus model. The reference model is called Virus by Yuri Wylensky, and it explains how it works, how the density of the population, the number of people that appears initially in the population affects the simulation, and the chance to recover, and how immunity works, and so on. So here you have all the explanations, and now we can go to the code, which might be the most interesting part. So here we have several variables that are local to the individuals. You know that in NetLogo we call individuals or agents as turtles. So they have a variable indicating if they are sick, if they are old, the chance they have to recover. That depends on the age. If they are old, the chance might be different. The days to remaining immunity, for how long has been infected. Here it says weeks, but it should say days. Sorry about that. And so I have changed that because it's days. sick time is how long the turtle has been infected. The age is how old is the turtle. It's computed in days. And if this turtle is allowed to move or not. And then we have different global variables, the percentage of infected individuals, the percentage of immune individuals, how long they can live, how many days immunity lasts, and if the simulation has ended or not, because we stop the simulation when no more people are sick. So you know that when we execute the model, we have this setup button that we need to press to create a different population, distribution of the population. So here we see what happens when we press the button. First we clear everything and then assign values for the constants, which is related to some variables. Let's see. This function here. What it does is to assign the values. So in fact, we say that the lifespan for individuals are 90 years. So it's 90 by 365 days per day. So it's a lot of days. And immunity duration has the number of days that immunity lasts. This value has been assigned just for the sake of testing. You can change that if you want, just a number to try how things work. And as I was mentioning, we have a variable that tells if the simulation has ended or not, which initially, of course, should be false, so we can run the simulation. So we had this initial setup of the constants, and what we also have to do in the setup, in the method of setup, is to create the turtles. So first thing, we create the turtles, as many as the initial number of people has been assigned in this slider. Okay, so here in the code we take this value and create as many turtles as that with a random position and a random age. Depending on the value of this age, we will set to true the variable old. And initially they are old non-sick, but there is one turtle randomly selected that gets sick. What does it mean to get sick? To get sick is that the variable sick becomes true and the days of immunity are still 0. Okay, so once we have created the turtles, we have to update global variables to start with. So when we come here, we are showing number of variables and we need to define these values. So update global variables here. Whenever we have enough turtles, what we will do is to compute the percentage of infected turtles, that is how many of them are sick, with respect the total number of turtles and how many of them are immune. Here also we assign the value of simulation, okay, of ending simulation. It will become true when no more turtles are infected. Coming back to our setup, we will have to update display. Which is in charge of changing how turtles are represented. So first, here we have different possibilities of how turtles will be displayed. It can be a person, a circle, or a way. We can edit this, and these are the values that we can have. The third one is person age. We will see now how it is handled. So in the code, first we will say that when the person age option is selected, we will make a difference between those older than 60 years, which will have this stick. It will be visualized with this stick, and if not, they will be visualized as regular persons, as this typical persons. Moreover, if they become sick, they will change color to red. Otherwise, if they are immune, they will become gray, and if not, which means they are healthy, they will become green. Okay, so we have these different individuals, grays, reds, and greens. And for the elders, it's the same. It will be only on the face that can be red, or can be gray, or let me see, or healthy. So far we are done with the setup. The setup will reset tick, so initially the tick counter will start to 0 value, and then as we will do in the execution, we will press go and go to the code of go. So as far as the simulation is not ended, what we will ask the turtles is to get older. That will mean they will increase their age, and the counters of how long have they been sick, or remaining immunity. All these variables are updated. Then they move the move method, as its name indicates, chooses a random direction to turn, and then they move forward as far as they are allowed to move. And then a turtle, they will check if they are sick. They might recover or die. So recover or die method is here, and it really depends on the chance of recovery that this individual has, that they will recover and become immune, or this individual will pass away, will die. that was this line in the Go. And there is another thing that can be done, which is if you are sick, you might infect others. So let's go to the infect. An individual might infect another if this individual is sharing the same patch, it's located at the same position with another individual that it's not sick and it's not immune. Okay, how the transmission, it will depend on the infectiousness value, which is a variable that is specified here, that our default value is 100, but it could be, it can be changed in the simulation. And that will make the other individual to get sick and get sick. Is specified here. What does is to change the variable sick to true and initialize the remaining immunity local variable. Okay, so once we press the button go, all turtles do these things of getting older, move, and recover or infect others. And again, we update constantly global variables and the display, and new tick. The counter of ticks is increased, so this is repeated for as long as there are sick individuals. Okay, you can have a look at the code, but this is most of the explanation.